In this video, I'm going to go through the solution to question 28 of the 2025 Australian Math Competition Intermediate Paper. In the game of rhombus blockade, players place rhombuses of any size within this triangular board so that their edges line up with the triangular grid. For the opening move, the first player places a single rhombus of any size on the board. For example, the diagram shows an opening move where the player has chosen and placed a rhombus with sides of length 3. How many possible opening moves are there? So, notice the orientation of this rhombus. Kind of looks like this, right? There's a there's a side that's parallel to this side, there's a side that's parallel to that side, but there's no side parallel to player 3 side, right? That's one possible orientation. However, we actually can put it in different orientations. You can see there's one side, which is this side, that doesn't have an edge of the rhombus parallel to it. So maybe instead of player 3's side, it is player 2's side. So maybe we get this orientation. And if it's player 1's side that doesn't have a side of the rhombus parallel to it, it'll look like that. So there's 3 different orientations for our rhombus. And what do we know about that? I'm going to claim that each of these orientations is going to have the same number of rhombuses. So, how do we know that? If I take this top right, top left corner there, that's of the first orientation. What I could do is I could actually spin this whole triangle around. By symmetry, there's one here and there's one here of our 3 different orientations. The same with this red one that they've given us. I'm able to just spin it around a bit and I'm going to get a rhombus here. And I'm also going to get a rhombus here. Just by symmetry, I can see that. So each of these 3 orientations, there is the same number of rhombuses. So in that case, we can only count one. We can just count one of these orientations and then multiply by 3 at the end. Now we're going to count by side length, of course, because they've given us a side length of 3. So let me wonder what the side length could be. If the side length is 1, then what happens? Well, if the side length is 1, of course, we can place it on the first row, just like this, the top left corner. I can put it here, here, right? I can put it in any of these spaces up until I reach the end here. 1, 2, 3, 4, 5, 6, 7, 8. So I can say that if the side length is 1 and it's in the first row, there's 8 different possibilities. Watch what happens when I go to the second row. 1, 2, 3, 4, 5, 6, 7. And I reach the end here. I can't go any further. Second row, I have 7. You should be able to see the pattern by now. Every time I go down one row, there's one less spot to place it in because each row there's 2 less triangles at the end there. So eventually, the most bottom I can put it is down here. 1, 2, first, second, third, fourth, fifth, sixth, seventh, eighth row, there's going to be 1, right? So what's the total number of rhombuses of side length 1 of this orientation? That's just 8 plus 7 all the way down to 1. If you know the formula for the arithmetic series, it's the first number plus the last number times the total number of numbers, which is 8 divided by 2. So 8 divided by 2 is 4. 8 plus 1 is 9. 9 times 4, 36. Okay. What happens if the side length is 2? Well, let's see. We can put it here. 1, 2, 3, 4, 5, 6. And we've reached the end there. So the first row, there's 6 different places. The second row, 1, 2, 3, 4, 5. This is the last spot I can place that. Again, there's the same pattern. When you go down a row, there's one less spot to place the rhombus. So in a very similar fashion, this is 6 plus 5 plus 4 plus 3 plus 2 plus 1. As you can see, this is the most bottom you can put that rhombus there in the 6th row. So this one is 21. Now side length 3. Should be able to see what happens now because this is side length 3. 1, 2, 3. And then when you get to here, you're going to hit the wall of that. So there's 4 different places you can put on the first row. So 4, 3, 2, 1. So there's 10 rhombuses of side length 3. Side length 4. Well, if you put it in the first row, it's already going to go down to here, right? And you can put it there, or you can just go down like this. So side length 4 is 2 plus 1 equals to 3. And we can see that you can't possibly have any bigger side length, even if you tuck it right up in the corner. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You're going to go out of the board, right? That place is not in the board. So side length 4 is the biggest one you can get. Of course, if you continue this pattern, side length 5, it's going to start from 0, which is not good. So we've counted the number of rhombuses of all the side lengths. So let's add them up. 36, 21, 10, and 3. I believe this is 70. Okay. But remember, we only counted one of the 3 orientations. So please don't forget about that. So we have to count all 3 orientations. So we have to multiply by 3 at the end. And we get 210, which is our final answer. And we are done.